This is SpaceTime Series 29, Episode 100, for broadcast on the 21st of August 2026. Coming up on SpaceTime, a new study says the ingredients for planets may have formed much earlier than previously thought. Hunting for the hypothetical Axion, which could explain a lot of the missing physics in science. And good news, with NASA's Swift rescue mission back on track. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggested the basic ingredients needed to form planets, and possibly life, may have existed just a few 100 million years after the Big Bang, far earlier in the history of the universe than previously thought. Scientists had previously assumed that planet formation was a slow, long process, only really getting going several billion years into the universe's history. The very first stars in the universe, known as population 3 stars, were enormous, hundreds of times the mass of our Sun. They were unique, formed out of the pure primordial hydrogen and helium created in the Big Bang 13.8 billion years ago. They were the hottest and most luminous stars that ever existed. Nothing like them exists today. And being so massive and hot, they burned through their nuclear fuel supplies at an intense rate, only living for very short periods of time, perhaps just 100 million years or even less. That compares to the expected 12 billion year lifespan of a star like our Sun. And when these first-generation stars died, they ended their lives in powerful supernova explosions. Both during their lives and as they died, they produced all the other elements in the universe, elements which simply didn't exist beforehand, including all those needed to build planets, and ultimately life, such as carbon, oxygen and iron. The new findings, reported in the journal Astrophysical Letters, shows that the precursors of terrestrial planets could form around low-mass, long-lived stars in the debris of the first cosmic explosions 100 million years after the Big Bang. One of the study's authors, Daniel Whalen from the University of Portsmouth, says a specific type of population 3 supernova, called a parent stability supernova, is so powerful it can blast out more than 100 times the mass of the Sun's worth of heavy elements in a single explosion. And this material would then seed and enrich nearby clouds of gas, resulting in surprisingly high concentrations of heavy elements. And those enriched clouds could then collapse under gravity to form swirling protoplanetary disks of material around young nascent stars, much like the disk from which our own solar system formed. Whalen says his team's computer simulations of the early universe looked at just such a protoplanetary disk around a young star with about 70% the mass of the Sun. And within that disk, enough solid material had accumulated to create several Earth-mass planets at roughly the same distance from the star as the Earth is from the Sun. Most surprisingly, the disk also contained substantial amounts of water, only a few times less than what was available when our own solar system was formed. Now what this means is that any planets forming there could potentially have received water in a way similar to the Earth, which is thought to have gained much of its water from material left over during planet-building processes. The new findings suggest that the conditions for planetary formation may therefore have existed much earlier than previously thought. And if that is the case, it raises an intriguing question. Could potentially habitable worlds have appeared far earlier in the universe's history as well? This is SpaceTime. Still to come, hunting for the hypothetical Axion, and good news with NASA's Swift rescue mission back on track. All that and more still to come on SpaceTime. For years, scientists have been hunting for a hypothetical elementary particle called the Axion, which could lead to new physics, unlocking some of the greatest mysteries of the universe. Now, the German Research Foundation has given the green light for the construction of a new €6 million experiment to be called Baby Yaxo, a first step in the search for this elusive and as yet undetected particle. The Axion was first theorized back in 1978 by physicists Frank Wilczek and Steven Weinberg. Its discovery would revolutionize the standard model of particle physics, the foundation stone of science's understanding of the universe. If it exists, the Axion could well be the long sought-after candidate for cold dark matter, that mysterious invisible substance that makes up 85% of all the mass in the universe. And it could also explain the strong charge parity problem in quantum chromodynamics, why the neutron has virtually no electric dipole moment balancing charge symmetry. The Baby IXO experiment will use a 10-metre-long cryogenically cooled superconducting magnet operating at around minus 270 degrees Celsius on a moving platform tracking the sun across the sky for 12 hours a day. The magnet needs to be operated at around minus 270 degrees Celsius to achieve the necessary magnetic field strengths. The project coordinator, Matthias Stott from the University of Bonn, says the Baby IXO project will be the largest dipole magnet ever constructed in particle physics. He describes it as the beating heart of the experiment, what makes Baby IXO possible in the first place. The experiment itself will be built at the DESI Research Center in Hamburg. Now, as the name suggests, Baby IXO represents an intermediate stage on the journey to an even bigger, fully grown magnetic system, the International Axion Observatory, or IXO, which will be twice as big using a 20-metre-long magnet. This telescope will study the sun at unprecedented levels of sensitivity, some 10,000 times more efficiently than the most powerful helioscopes used today. IXO will have 8 measuring stations, each kitted out with various telescopes and detectors. It'll let scientists look for axions with varying ranges of properties, and it will allow scientists to develop the technologies and instruments that IAXIO will need. Of course, it'll be just the latest in an ongoing hunt for the elusive particle. Among the many experiments already searching for the axion is the Lawrence Livermore National Laboratory in the United States.
Dark matter is a mystery that we've had in physics since the 1930s. If you look at the way galaxies move and the way stars move around them, there's got to be a lot of unseen matter holding the galaxies together. Nothing in the periodic table or in the standard model could possibly make up for it. We know what dark matter isn't. We know it is not nuclei or gas in galaxies. We know it's not deviations from gravity. And we know it's not other particles in the standard model like the neutrino. So it's got to be something new, and the particle that we're looking for is called an axion. Axions are extremely light particles that were first postulated to solve another problem in the standard model. These axions are extremely light. You can think of them more like radio waves, and they'd be about 10 to the 14 per cubic centimeter. So we're taking data right now. We don't know where the axion's mass is, so we're tuning the experiment over frequencies. We could find it tomorrow, or it may take a decade to look for it. But the experiment is continually being upgraded so we can scan faster and faster to hopefully detect it very soon. So the experiment started here at Lawrence Livermore. We have a collaboration between UC California, Berkeley, University of Florida, University of Washington. And since then, the collaboration has grown to a number of national laboratories and universities, both domestic and internationally. The equipment we're using is the Axion dark matter experiment. So we have an 8 Tesla magnet. It's located at the University of Washington. It was actually started here in the lab many years ago. We have a microwave cavity, and that resonant cavity stimulates the conversion of these axions to detectable microwaves. We're looking for tiny amounts of power, like 10 to the minus 24 watts, so tens to hundreds of photons every second. So we need to use quantum electronics to be able to boost that into a detectable range. And then at that point, it's basically an AM radio. You're turning the dial, looking for small tones, small excess of power above the background noise. The dark matter experiment really uses cutting-edge quantum electronics. These quantum amplifiers that have been built at UC Berkeley for us are also used to read out qubits, and those qubits can be used for quantum computing. This is a high-energy physics experiment that uses a lot of the same technologies that will be used for quantum computing in the future. Well, finding dark matter has been one of the major problems in physics for almost 100 years now. So this would be a major victory in physics in the standard model. In addition, the axion itself would have a lot of information encoded into its frequency structure. You'd see information as the Earth moves around the sun, as the sun goes through the galaxy. You could see that frequency shifting around. And so the Axion dark matter experiment would become basically a dark matter telescope. It's possible this is a new particle that is unlike anything we know of, so there could be other potential practical applications in the far future.
That's physicist Jean-Paolo Carossi from the Lawrence Livermore National Laboratory. And this is SpaceTime. Still to come, good news with NASA's Swift rescue mission back on track. And later in the science report, a potential cure for baldness. All that and more still to come on SpaceTime. Catalyst Space have successfully uploaded new flight software updates designed to return its Link spacecraft into a more stable configuration. Link is on a rescue mission to try and save NASA's Swift Gamma-ray Space Telescope. Swift provides scientists studying the most powerful explosions in the universe with an early warning system. These explosions, called gamma-ray bursts, only last a few seconds, and Swift gives astronomers a much-needed heads-up, giving them the time they need to turn their telescopes towards the blast. The problem is, Swift was launched without any means of boosting its orbit should that orbit decay. And the recent solar maximum climax of the Sun's 11-year solar cycle has proven to be far stronger than anticipated. The increase in solar storm activity has sent powerful flares and coronal mass ejections hurtling towards the Earth. And as they hit the Earth's atmosphere, it causes it to expand and contract, sort of wobbling like jello. And that's placed extra atmospheric drag on the Swift Space Telescope, causing its orbit to decay. Without help, Swift will re-enter the atmosphere in the next few months, burning up as it plummets back to the surface. And that's where the Link spacecraft comes in. It's designed to rendezvous with Swift, maneuver around the orbiting observatory, and grab onto it with its 3 robotic arms. It'll then fire its thrusters, boosting Swift back up to its original 600-kilometre high orbit. At least that was the plan. However, after its launch aboard a Pegasus rocket, Link experienced an unexpected electrical power system anomaly during its orbital commissioning. This caused an uncommanded electrical bus reset, and that disabled 2 of the spacecraft's 3 orientation-controlling reaction wheels. It also degraded its cold gas thrusters, which are used for fine guidance control. The end result was that it sent the Link spacecraft into an uncontrolled multi-axis tumbling spin, rotating at around 9 degrees per second, causing communication dropouts. The Catalyst team have used a series of engine burns from one of Link's gimbaled electric propulsion thrusters to slow that spin rate down to a more manageable 1.47 degrees per second. And the new uploaded flight software patch has further rectified some of the other issues affecting the spacecraft. Now, this has all prepared Link to continue its approach towards the Swift spacecraft, performing a series of burns and maneuvers to align Link's orbit with that of Swift, before attempting to capture and raise the telescope back up to its higher orbital altitude. Mission managers are now carefully evaluating remaining subsystem performance options before attempting any complex rendezvous operations with Swift. If all goes to plan, Link will make its first rendezvous attempt with the orbiting observatory sometime in the next week. Now, if the capture succeeds, Link will spend several months using its thrusters to boost Swift back up to its higher orbit. Mind you, the reboost needs to begin before Swift falls below the 300-kilometre mark, and at the current rate of descent, that's only a few months away. Below that threshold, atmospheric drag will become too intense for Link to safely rescue Swift. Needless to say, we'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. 2 new trials have shown that a drug called upadacitinib was able to restore scalp hair growth better than a placebo in people with alopecia areata, a chronic immune disease that causes hair loss. The study, reported in the Journal of the American Medical Association, found that people taking the drug were able to achieve at least 80% coverage of their scalp with hair in about 45 to 50% of cases, compared to just 1.5 to 3.4% for those on the placebo. The study didn't find any new safety concerns with the drug, which is already being used for several other inflammatory conditions. Well, it turns out that regardless of your cultural background, people, generally speaking, are most ticklish on their neck, their armpits, their belly, and on the soles of their feet. The findings, reported in the journal Nature, are based on a study of 500 people with Chinese, Dutch, and Greek backgrounds. 2/3 enjoyed tickling others, and most associated it with playfulness and making others laugh. However, only a third of those agreed that people actually enjoy being tickled, and half admitted the laughter didn't reflect genuine enjoyment. The authors say areas of the body that aren't often tickled tend to be more ticklish, and were the same areas that were also less sensitive to pain or sexual pleasure. And that suggests that ticklishness is a different kind of sensation. Scientists have discovered a fossil of what is now the earliest known sulfurical-bearing cephalopod ever found, dating back some 520 million years to the early Cambrian of South China. The findings, reported in the journal Nature, provides new insights into the early origin and evolutionary history of one of the major animal groups in existence. Cephalopods include octopi, squids, cuttlefish, nautiluses, as well as extinct ammonites. These marine creatures utilize a tube running through their shell chambers called a sphinnicle, which can be filled with water or gas to regulate buoyancy. It's one of the key evolutionary innovations that distinguishes cephalopods from other mollusks. The new discovery, named for Ceros shanzians, is just 1 millimetre in size, with an orthoconic shell. A new study has shown that moving your pet cat from outdoors to indoors is a lot easier than many owners expect. And more importantly, it'll improve feline welfare, protect wildlife, and ease concerns about keeping kitty cats safe. A report in the Journal of Applied Animal Behaviour Science surveyed 87 cat owners, revealing that most who transitioned their pets from outdoor living to indoor living reported that the change was ultimately worthwhile, with benefits to both the cat and the owners clearly outweighing the challenges. And over 2/3 found the process was far easier than expected. The study's authors say owners certainly faced some challenges during the transition, especially in the first few weeks. But most found these were temporary and that the long-term benefits far outweighed the difficulties. The study by the University of Adelaide found that at least half the cats adjusted to indoor living within a matter of weeks, with younger cats generally adapting more quickly than older ones. A little old lady in Germany has spent the last few months chasing a strange UFO in the night skies. The skeptic's Tim Mendham says her bad eyesight had a lot to do with it.
A really nice article came out about what seems to be a very nice fellow named Hans-Jürgen Köhler, who's in Germany. He runs a UFO reporting organisation, and he seems to be a nice fellow who gently disabuses people of their claims. He doesn't mind getting up in the middle of the night when someone reports some very strange observance, and he says that most of these things are very easily explained. He was saying that in his group, they've processed 13,621 reported UFO sightings since it was founded in 1976. So that's how many years is that? 50 years? And has been able to explain almost all of them with only 89 cases unresolved. The thing you've got to watch out for is unresolved doesn't mean resolved. It means unresolved. And it's what the U of unidentified flying object means. It's unidentified, which means you don't jump into suddenly saying, I don't know what it is, therefore I do know what it is. But he sort of points out that, he gets all these phone calls, all these organisations. There's a whole bunch of them in Germany for a start, but all these organisations are always getting calls from people. And he says a lot of them are at night. This is his theory. A lot of them at night when people walk out onto their balcony to have an evening cigarette and they look up into the sky and they see something they've never seen before, primarily because they don't look up into the sky very often, except when they're having a cigarette. All sorts of stories come about where people see things that they haven't seen before, so instantly they say it must be unexplained. Well, unexplained to you maybe, but not for everyone else. A classic one, and a rather sad one, probably in the extreme, was a lady who reckons she would see this flying saucer that was growing bigger and smaller, etc., and she chased it all across Germany and into some other countries nearby. And after a bit of investigation and discussion with her, Köhler found out that the lady was very hard of sight, just half blind. She'd lost her contact lenses and was wearing defective glasses. And what she was spotting was not a UFO. It was actually the moon, waxing and waning. She chased this thing for months. And he said it was odd, it sounded dramatic, but in the end, it probably just the fact that she was a lonely old lady who was looking for something exciting in life and thought she had found it by following the moon and thinking it was a flying saucer, UFO, UAP, whatever you call them these days.
I still get people asking me about the planet Venus.
Yeah. How long have people been mistaking Venus for an unknown object in our sky? For years, donkey's years. Mainly because it's there at the setting of the sun or the rising of the sun. People go out and look at it. They see what seems to be a very bright light, which it is, and they say, oh, that's only just up above the horizon. Well, it's not. It's actually tens of million kilometres away. And yet it still crops up all the time. Venus, all the time, quite regularly. People driving and they say it's moving. No, you're moving. It might be moving against your foreground, but it's still up there. But yeah, Venus, cloud formations, atmospheric conditions, balloons are the big thing these days.
That's the skeptic's Tim Mendham, and this is Space Time. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.